Hello everyone, welcome to week 7 of NOC Detailing series. I am Rajvijay, a senior design manager at TrueSilicon Technologies. A few weeks ago, we talked about the requirement of cache and its hierarchy. At the end, we also talk about the multi-core system. What happens when two different processors want to modify exact same piece of data at exact same time. If they aren't perfectly synced, your system will process corrupt data. Today we are breaking down hardware cache coherency, especially battles between the snooping and directory based architecture like Snoop Filter. Let's dive in it. Imagine core A reads data from main memory, bring it into L1 local cache and change its value from 0 to 1. Later a millisecond, core B read the same variable and if core B reads from the memory, it will see it as 0. Core B now operating on incorrect data. We need a hardware mechanism to ensure every core always see a most updated value of the memory, and that's the hardware cache coherency. So what are the options? First of all, it's a snooping. Snooping you can think about it's a open plain office. If I need a latest copy of any file, I just stand up and shout to the entire room. Everyone will listen to me, and whomsoever has a latest copy, he or she will return to me. So the same way in hardware, NOC broadcast a Snoop request across the shared bus. Everyone other cache listen in and snoop and respond it if they have the data. Snooping is incredible fast and has low latency, making it perfect for the smaller customer. But as you scale up to 16 or 32 cores, all that shooting create a massive congestion on the interconnect. When we build a massive system, highly scalable SoC, you cannot rely on the broadcast. You have to switch to directory based architecture, in which modern interconnect is typically implemented using a Snoop filter. So, what is Snoop filter? Instead of shouting to room, imagine a dedicated librarian. The librarian holds a master list, the directory that tracks exactly which person has which file. If I need a spreadsheet, I don't shout. I just quietly ask to the librarian. The librarian checks the Snoop filter and sees that only Core C has that copy. So directly from Core C, it will deliver. By filtering all the unnecessary Snoop, a Snoop filter, centralized hardware controller, eliminates massive amount of broadcast traffic. It takes slightly longer time to look up the directory, but for a large scale mesh nodes, a Snoop filter is only the way to manage hardware coherency effectively. At TrueSilicon, we engineers every day deals with a complex NOC that carries this hardware cache coherency seamlessly across the mesh. Are you currently working with any Snoop filter or any other cache protocols? Let's talk about their trade-off in comments. Also, make sure to hit like and follow. We'll see you in the next Monday. Have a good day.